Hello my dear students, how are you? Welcome back. What a joy to see you back. How was the quiz? Good? That's good to hear that. Good, keep up the good work, continue doing all your quizzes. It makes a huge difference in your success. Alright, well, welcome to lesson 2. In this lesson we're going to talk about patterns and sequence. Well, what is patterns and sequence? Now, sequence, it's a set of numbers that follows a certain rule that forms a pattern. What do I mean by that again? Okay, sequence, it's a set of numbers that follows a certain rules. So what do I mean by that? So for example, if I have 1, 2, 3, 4, 5, 6, 7, see that? That is a pattern. See how the number sequence is? 1, 2, the increment is just by 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. See that? That is the sequence and has a pattern to it. See that? Okay, let's look at another sequence. 2, 4, 8, 16, 32. Can you tell the pattern of that sequence? 2, 4, 8, 16. See that? I'm multiplying each number with 2. So in other words, I'm doubling it. Alright? See that? That's another pattern. Now how about 16, 8, 4, 2, 1. See how it's decreasing from that sequence? So what kind of pattern is that? I'm dividing it by 2. See that? So in other words, the pattern, the sequence of a number, set of number, alright? When the pattern can be the adding, subtracting, multiplying, or dividing. Alright? So let's look at the board. Okay, let's say Mr. Max put a sequence, okay? So I put a sequence of number, right? Say we got 3, 6, 9, 12, 15. Look at that. It's increasing. But we want to find out how it's increasing. What kind of pattern is that? Actually, we are adding 3 to it. 3 plus 3 is 6, plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So now if I ask you, what could be the next sequence? Of course, you just add 3 to it, okay, which becomes 18. Now remember, in the sequence, the pattern is consistent. In other words, you can't have plus 3 here and then plus 6 here and then it doesn't change. It has to be consistent. If you're adding 2, you're adding 2 all the way through. If you're adding 5, you're adding 5. You're subtracting, alright? Let's say for example, okay, if I have 25, 20, 15, 10, see that? What kind of sequence is that? I'm subtracting it by 5. See that? See, reducing from 25 to 20, because 25 minus 5 is 20, 20 minus 5 is 15, 15 minus 5 is 10. So what would be the next sequence? 10 minus 5, which is 5. Now, this is called arithmetic sequence. When you add or subtract, you call that arithmetic sequence. Now let's look at the geometry sequence. Geometry sequence is when you multiply or divide. Okay, let's say for example, if I have 2, 4, 8, 16, 32. So what kind of pattern is that? I'm multiplying it by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So what would be the next number? What would be the next sequence right here? 32 times 2, which is 64. See that? How about this one? Let's say if I give you 125, and then let's say, and then 25, and then 5. What kind of sequence? This is a sequence. What kind of pattern is that? I'm taking 125, dividing it by 5. See that? 125 divided by 5 is 25. And then 25 divided by 5, it's 5. And so what will be the next digit? Exactly, 5 divided by 5 is 1, right there. Isn't that awesome? Pretty easy, isn't it? So this is called geometry sequence, and this is called arithmetic sequence. Okay, so arithmetic involves addition and subtracting. Geometry involves multiplication and division. Okay, so let's say, for example, now let me give you a problem. Okay, let's say if I give you, let's say 4, let's say 8, and then I put 16, 20, and ask you to find the missing number. Now be careful here. Look at this. There's a chances you may say, well, look like 4, 8, 4 times 2. So this must be 8 times 2. But 8 times 2 is what? 16. But look at that. I give you 16 right there. It's not a good sequence. Am I right? How about 4 plus 4? 8. 8 plus 4. 12. 12 plus 4. 16. 16 plus 4. 20. That's why you have to be very careful. Okay, don't make a quick judgment from the first two. Look at the other numbers. Even when you find the answer and see if that has the same sequence. Okay, the pattern is still the same. Okay, let's say for example, we kind of thought could be times 2. So 4 times 2 is 8. 8 times 2 is 16. 16 times 2 should be 32, but it gives me 16. So that means you know that that's not the right sequence. Okay, right pattern. And then you go back and look for a different one. This time, how about add 4? 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. See that? That's how you make the reasoning, all right? Trying to fill up the blank, okay? Let's say, for example, let's do another one. Let's see if I give you 15. And then I told you 25, 30. And ask you to find this. You say, well, Mr. Mac, you give me right away. That's fine. Look at this one. 25, 30. So this tells you it could be plus 5. See that? So it just could be. Okay? Try it first. Alright? Okay, let's say we say plus 5. Okay? 15 plus 5 should give me 20. 20 plus 5 give me 25. There you go. That confirms that you're right. Okay, so that's why you got to be careful. Okay, don't make a hasten. Like for example, the moment you realize, oh, it could be 5 plus 5, try it, plug it in, try it. Plus 5 gives me 20. 20 plus 5 gives me 25. 25 plus 5 gives me 30. Ah, the pattern does bring the sequence. See that? And that's how you do it. Okay, so it's very important to understand the sequence. Okay, what are the 4 different type of patterns in the sequence? Addition, subtraction, multiplication, and division. Okay, these are the 4 different ways you've been utilized in the sequence. Okay, all right, my dear students, how about we do this? Mr. Max is going to erase the board. I'm going to put few patterns on the board. Okay, the sequence with the patterns, and then I'm going to put some blanks. And I want you to fill in the blanks. Find out what the missing number of the sequence. Okay, so you need to find out what the pattern is, and then you fill in the blanks. All right, and give me a few seconds and I'll be back with you. All right, my dear students, I got 4 problems listed on the board. Let's do it together. Okay, now you may have a question. Ask me, Mr. Mac, all right, this is more like looking and making a guess. Am I right? Mathematics is not like looking and making a guess. You're right. We don't make a guess trying to figure out, because it could be time consuming. You might wonder like, well, could it be 4? Could it be 5? Or could it be 6? See that? So there got to be a way of finding whether it's an addition sequence, or it's a subtraction, or multiplication, or division. Am I right? Okay, that's how I'm going to show it to you in these problems. All right. Earlier, I was just kind of taught you how to, by looking at it and coming up with the answers. All right. Especially if it's a simple sequence. If the sequence gets a little bit harder and the pattern is gonna get bigger, okay, or tougher, hard to come conclusion what type of pattern it is. All right, let's look at the first one. Look at this one. You got 54, 64, and then you got 2 blanks, and then 94, 104, and you want to find out what kind of sequence this is. Okay, well, by looking the way the sequence is, you can make that some kind of idea that pattern could possibly be addition. Why is that? Or definitely cannot be subtraction. Why? The number is increasing, and you can see it's not increasing it rapidly. All right, if it's increased rapidly, then you can make a judgment saying it could be multiplication. But in this case, it's not increasing rapidly. So it could be addition. All right. How do we tell that this one is an addition, and what is the pattern? Okay. So what you do is always take the second digit, subtract with the first digit. All right. Always the digit after subtract by the digit before or next to it. Okay. The one next to it before. Okay. So let's say 64. I'm going to subtract that with 54. So 4 minus 4 is 0. 6 minus 5 is 1. See, that gives me 10. So I can say this is adding 10. But wait a minute, I need to confirm it is true it's adding 10. I have to look for another two set of numbers next to each other. In this case, right there. And I'm going to do the same thing. Take the second number, subtract with the first number, okay? The following number before, and subtract with the before number. So in other words, I'm going to take 104, and I'm going to subtract that with 94. Okay? 4 minus 4 is 0. 10 minus 9 is 1. Look at that. If the difference of this two set of numbers and this two set of numbers gives me the same, that means it has been incremented by 10. The pattern is I'm adding 10 to the number, and that's the sequence. Okay, so I'm going to add 10 to this. That means if I add 10 to this one becomes 74. Add 10 to this becomes 84, and add 10 to this gives me 94. See that? See how the pattern is? So the sequence is nice, smooth sequence, all right? Because the pattern is adding 10 to it, all right? Okay, so there we go. Complete the following sequence. There we go. We complete it and describe its pattern. We're adding 10, or just put plus 10, and that's the pattern. All right, the pattern is we're plusing 10. Okay, so now let's look at B. Now B, look at B. 100. 85, 70. See that a sequence? What type of sequence is that? It's kind of decreasing. So the pattern is going to be what? Either subtracting or dividing, because the number is decreasing. All right. But again, how do we narrow down between subtraction and division? Because how do we differentiate? By looking at the sequence here, whether it's been using subtracting pattern or division pattern. But look at that. 185, 70. It's not changing rapidly. See that? So if it's a dividing, it will change very rapidly. In this case, it's not. Look at that. 100, 85, 70. That means conclusion I'm going to make is this could be a subtracting sequence. All right? The pattern is subtracting. Okay? So once I make that conclusion, this is going to be a subtracting sequence. What do? I get two pairs. All right. So again, now this is still, we haven't firmly concluded. This is the assumption we're making. We're still making assumption, but a strong assumption that's going to be a subtracting sequence. All right, with that pattern. So to confirm that, what do? We take two sets of numbers. All right. Now look at that with the addition. What we did when we know this one is going to be addition sequence. All right. The pattern is going to be an addition. We took two sets of numbers. All right, and we took the second number, subtract by the first number, and then we took another two sets of number. Okay, right there. Okay, second number, subtract by the first number. Now with the subtracting, it's the other way around. You still take the two sets of number, all right, but you take the first number, subtract by the second number. All right, so in other words, we're going to take 100 minus 85. And then you look for another set of numbers. Now let's say, for example, when I subtract this, okay, 0 minus 5, I can't, so I have to borrow from 10. 10 becomes 9, and 0 becomes 10. 10 minus 5 is 5. 9 minus 8 is 15. Now if I start concluding I'm subtracting 15, it could be correct, but still I want to confirm it that it is I'm subtracting with 15 by taking another two sets of number. But you think, well, where is another two set I can take? Like here I got two set, here two set. Right here, this is we can make another two set. 85 and 70. So I pick these two sets and make the first minus the second. So 85 minus 70. Okay, so 85 minus 70. And if that also gives me 15, that confirms I'm subtracting the numbers by 15, 15, 15. Okay, let's see that. 5 minus 0 is 5. 8 minus 7 is 1. There you go. That confirms it. The pattern is I'm subtracting by 15. That means 70 minus 15 is, very good, 55. And then minus 15 is 40. There you go. I filled in the blank. And what's the pattern? Exactly. Minus 15 is the pattern for this one. And then add 10 is for that one. Pretty easy, isn't it? Okay, so keep in mind, you got to find a pair, they're next to each other, and then first minus the second should equal to another set, first minus the second. Once you do that, then you know that you're subtracting with that number that came to be same. You're subtracting. So in other words, you're subtracting 15, 15, 15. Like in this case, you take the second minus the first, and then take another set, second minus the first. Alright? Okay, good. So now let's look at this one. Now again, look at this number. 4, 12, 36. See that? The number is just going quick. 4, 12, 36. So it's kind of rapid increment. And you know that it could be the addition or multiplication. Cannot be subtracting or division. Why is that? The number is increasing. But now, once you narrow down to addition and multiplication, we can narrow down further by looking the rapidness of the number, movement of the number, the sequence. 4, 12, 36. See, that's so rapid. That means it's going to be multiply. It's going to be multiply, alright? So, now we're going to find out what would be the multiplication. Alright, the multiplier for 4 to get to 12, 12 to get to 36. So what do? Again, you do the same thing. You take the two sets of, two sets. First set with the two numbers, and then another set, right there, two numbers. So you need two sets of number, and you want to compare them, whether they both has the same number when you divide them this time. What do I mean by that? You take the second number, you divide that by the first number, by that set. This set, same thing. Second number, you divide by the first number. The division, okay, the quotient has to be equal. Once you divide, the quotient of this should equal to the quotient of that. Alright, let's look at that. Okay, let's take 12. So we can take 12 divided by 4, and that's in our timetable range. It's what? 3. Now we're going to take this two set. 36 divided by 12. It's also a timetable range. 3 times 12 is 36. What that tells you? Yes, we are multiplying this by 3. See that? So now I can say multiply by 3, multiply by 3, multiply by 3. So 36 times 3. 3 times 6 is 18. Carry 1. 3 times 3 is 9. Plus 1 is 10. So the first blank is 108. And then I'm going to times that with 3. So I take 108 times 3. 3 times 8 is 24. 4, 2. 3 times 0 is 0. Plus 2 is 2. 3 times 1 is 3. So 324. See that? Pretty easy, isn't it? Alright? So you know this is multiplying it by 3. Now let's look at the D. Look at that. The number is 1024, 256, 64. It's going which direction? It's decreasing. It's not increasing. That means it cannot be what? Addition or multiplication, because the number is decreasing. So what it could be? Either division or subtraction. But look at that. Now, okay, let's say, okay, we narrow down to division or subtraction. Now we got to figure out between the division and subtraction. What is it? Alright? Look at that. Such rapid changes. From 1024 down to 256, and then down to 64. So that should give you the hint it could be division. And still we have to confirm that. How do we do that? Same thing. Like the way you're finding set of numbers, you make another set. Two sets, okay? These two are one set, and these two are one set. See that? Okay? Next to each other, right? So this time, take the first divided by the second. See earlier, second divided by first for multiplication. For division, first divided by second. When this set, first divided by second. Alright, so let's do that. Okay, so we're going to take 1024, divide that by 256. Okay, so what method we're going to use? We're going to use the long division method. Okay, so we're going to do the 1024 divided by 256. Okay, and this number is outside our exactly outside our timetable range. So we're going to use what method? The long division method. When I say the long division, what should come to your mind? The cage approach, all right? Well, Mr. Max is going to erase this part. Give me a few seconds. I'll be back with you. Okay, so let's do it again. Okay, I know I erased it over here. Okay, so what are we going to do again? We take the first digit divided by the second digit, and then with another set of the number, first digit divided by the second digit. So we want to find out that both gives the same number. If it does, that means we're going to divide each of that number with that number. All right, so let's do that. So let's take that 1024. We're going to divide that with 256. Okay, 256. So it's outside our range. Okay, so we're going to use what method? Long division method, which is cage approach. So the 1024 is kind of into Mr. Max, so 1024 I'll put inside the cage, and 256 I'll put outside the cage. All right, now first digit 1, there's no way you cannot do that. 2 digit 10, still too small, and third digit will be 102, still small. So then the fourth digit, which is 1024, but it's too big, it's outside our timetable range. So we're going to use the trial and error method. So that means we're going to take 256, we're going to make a guess. Let's say 3 and see how many. Let's say we're going to assume there are 3 256 inside there. So let's times with 3. 3 times 6 is 18, carry 1. 3 times 5 is 15, plus 1 is 16, 6 carry 1. 3 times 2 is 6, plus 1 is 7. So 768. Whoa, still look like we can add one more. So we can increase this to 4. So let's try 4. 256 times 4. 4 times 6 is 24. 4 carry 2. 4 times 5 is 20, plus 2 is 22. So I carry the 2, put the 2 here. 4 times 2 is 8, plus 2 is 10. Look at that. 4. So that means 4 works. Okay, 4 times 6 is 24. Put the 2 here. 4 times 5 is 20, plus 2 is 2. So and then I carry the 2. 4 times 2 is 8, plus 2 is 10. Subtract gives me 0. That means dividing this two number gives me 4. The assumption I'm making is I'm dividing this by 4 to get to that. Now I want to confirm whether same thing this and this. Dividing 4 is giving me that. So what do I have to do? I have to take 256, divide that by 64. And I want to see if that happens or not. Alright? So we're going to use what approach? The long division. But we already know 4. Okay, 4. Let's see, 64 times 4 gives me 256. Rather than dividing, let's multiply it. See that? That will confirms it. Because pretty much 256 divided by 64, we want to see whether it comes to 4. Reversing means what? 64 times 4 should give me what? 256. There we go. Much easier, isn't it? Rather than doing the division. So 64 times 4. 4 times 4 is 16. 6 carry 1. 4 times 6 is 24. 24 plus 1 is 25. Right there. Right there. See that? So that means that confirms that it is dividing it by 4. We are dividing it by 4. So to fill up this, we take 64 divided by 4. What would that be? Again, very good. We use the long division method because this is outside our timetable range. Okay, so 64 divided by 4. So we use the long division, which is the cage approach. 64 into Mr. Mag, I put inside the cage. 4 is kind of out, I'll put outside the cage. In 6, there's how many? 4? 1. 1 times 4 is 4. 6 minus 4 is 2. I bring the 4 down. Becomes 24. In 24, there's how many 4? 6. 6 times 4 is 24, minus gives me 0. Okay, so that means this will be 16. And then what do I do for this one? Very good. Again, I divide that by 4. That gives me 16 divided by 4 is 4. I filled in the blank. So what kind of pattern is this? Very good. Dividing it by 4. And what kind of pattern is this one? Multiplying it with 3. What kind of pattern is this is? Minus 15. Okay. And what kind of pattern is this one? Plus 10. See that? Pretty easy, isn't it? Alright? So make sure you understand this, alright? Plus, now how to find if it's adding, how to get to it. And then if it's subtracting, how to get to it. If it's multiplying, how to get to it. If it's dividing, how to get to it. Alright, boys and girls. Alright, my dear students. let's do this. Let's do some hands-on practice. That should be the best way for you to learn more. Okay, so I'm going to have some problems set up for you. Well, actually, I'm going to let Pablo, he's good, he's going to have some problems set up and then bring it to you, and then you work on it. All right, I'll be back with you in a few seconds. All right, my dear students, you ready for some hands-on practice? All right, let's call Pablo. He's busy doing something. Let's see what he's doing. Actually, he's preparing the hands-on practice, and look like he's almost done. Are you done, Pablo? Yep, he's done. Come on over, Pablo. Bring the sheet over. Bring the worksheet over. So our students are ready to do some hands-on practice. Here it is. All right, my dear students. Once Pablo hand over the sheet to you, go ahead, pause the video and have fun with it. All right? Okay. Then after you're done, invite Mr. Mac in. All right, tigers, go get him. Have fun. Only 4 questions, Pablo. How do you do? Good? Awesome. Good to hear that. All right. I know it's 4 is perfect. Okay. All right. Let's look at the question. It says complete the following sequence and describe the pattern. All right. So let's do the problem A. Okay. Problem A. You're given a sequence which is 304, 331, and then 358. And then 2 blanks. Okay, so we're going to complete the sequence. All right, so now first look at the question. Look at that sequence. You got 304, 331, 358. What kind of sequence is that? Okay, what kind of pattern do you think it could be? Because it's increasing, so it could be either addition or multiplication. Good. So we kind of eliminated subtraction and division. So now we're going to concentrate multiplication and addition and multiplication. So now we're going to narrow down between that two and find out which one it is. All right. So now look at it. 304, 331, 358. Is it a rapid increase? No. See that? It's kind of slow increase. So that means it could be a addition. All right, the pattern could be an addition pattern. Okay, so now we're going to confirm. Now we're going to find out what is the pattern and is it possible an addition pattern. All right. So how do we do that? We find 2 sets. First set and 2 sets right there. See that? One set of the numbers and another set of the numbers with a pair. Very important, going to be a pair. Okay, so what do? We take the second number minus by the first number. So we're going to take 331, we're going to minus with 304, because that should be equal to this set, second number 358, we're going to minus with 331. So they both has to be same. All right, so let's do that. Minus that. 1 minus 4, I can't. Borrow from 3. 3 becomes 2. 1 becomes 11. 11 minus 4 is 7. And then 2 minus 0 is 2. And then 3 minus 3 is 0. So it comes to 27. Let's see if this one also turned out to be 27. 8 minus 1, 7. 5 minus 3 is 2. 3 minus 3 is 0. Aha! It is 27. That means we are adding 27. 27. See that? So now to fill up this 2, we take 358, we plus that with 27. 8 plus 7 is 15. So 5, carry 1. 1 plus 5 is 6. 6 plus 2 is 8. So then bring the 3 down. So this one becomes 385. And then for another one, we add also another 27. Okay, so we're adding 27 right there. So 5 plus 7 is 12. So 2, carry 1. 1 plus 8 is 9. 9 plus 2 is 11. Okay, so I put 1, carry 1. 1 plus 3 is 4. So that gives me 412. So what type of pattern is this? Plus 27. Plus 27 is the pattern. See that? Pretty easy, isn't it? All right, let's look at problem B. Problem B, you're given 254, 217, and then blank, and then 106 and 69. Look at that. What kind of a sequence is that? It's decreasing. See that? 254, 217, and then we got 2 blanks, and then 106, 69. Is it a rapid decrease? No, it's kind of slow decrease. See that? That means it could be what? For sure it's not going to be addition or multiplication because it's decreasing. So it could be subtraction or division. But since we already found out that this is a slow decrease, so it's going to be what? Subtraction. So it cannot be division. Alright? So what do we do next? Now we find two sets of numbers with two numbers with it. Alright? So two sets with two numbers in it. Okay? So this is one set and this is be another set. Okay? So now we got found two sets. So what we do? We take the difference of the first number with the second number. For subtraction, if you think this is going to be subtraction, you take the first number, subtract by the second number. So we can take 254 minus, line it up, and that should equal to 106. First number, subtract by the second number, and they both has to be equal. Alright, so let's do that. 4 minus 7, you can't. Borrow from 5. 5 becomes 4. And 4 becomes 14. 14 minus 7 is 7. 4 minus 1 is 3. 2 minus 2 is 0. Okay? Now let's look at this one. 6 minus 9, I can. Borrow from 10. 10 becomes 9. 6 becomes 16. 16 minus 9 is 7. 9 minus 3 is 9 minus 6 is 3. See, they both gives you 37. That means I'm subtracting 37. So 217 minus 37. 7 minus 7 is 0. 1 minus 3, I can borrow from 2. 2 becomes 1 and 1 becomes 11. 11 minus 3 is 8. And then bring the 1 down. So it becomes 180. And then minus another 37. So I take 180 minus 37. 0 minus 7, I can't. Borrow from 8. 8 becomes 7. 10 minus 7, 3. 7 minus 3 is 4. Bring the 1 down. So it's 143. And minus 37 will give me 106. Minus 37 gives me 69. See that? Okay, so we filled in the blank. And what's the pattern is? Minus 37. Very careful, this minus, okay? So you got to mention minus 37 because this is a subtracting. Alright? Okay, the first one was plus 27. Okay, good. Let Mr. Mac erase the board and then we'll do problems C and D. I'll be back with you in a few seconds. Alright, ready for problem C? Okay, C is given. Now look at C. Oh, the first two is blank. Doesn't matter. I know you got it. You got it, didn't you? Good job. I know it's kind of challenging, but that's okay. We'll do it together, okay? Alright, so 96 and then 384 and then 1536. Now look at that. Now doesn't matter, the first two is empty, but look at this sequence. Make this as the way to use this 3 as a way to judge, to find out what kind of a pattern or sequence it is, okay? Look, 96, 384, 1536. It's such a rapid increase. See that increase? So for sure we know it's not going to be subtraction or division, and it's going to be either addition or multiplication, but such a rapid increase, so we know it's for sure it's going to be multiplication. Okay, so if it's multiplication, again we use the same principle. Find two sets of number, all right, with the pair. Okay, so if we know if it's going to be multiplication, what do we do? Take the second number divided by the first number should equal to this set, second number divided by the first number. So let's take this too. Okay, so we can take 384, we can divide that by 96. Do you notice that? With the addition and subtraction, we can add and subtract approach we used. With the multiplication, we're going to use a division approach. Alright? Okay? So with the addition and subtraction sequence, what approach we use? The subtraction approach. With multiplication and division, we're going to use the division approach. Alright? Okay, now let's do. We got big division, which is outside our timetable range. So we're going to use the long division method. When I say long division method, what method do I use? What approach? The cage approach. So I'm going to put the cage. 383 is kind of into Mr. Mac. I'm going to put inside the cage. Okay, and then 96 is kind of out. I'm going to put outside the cage. Now look at that. first digit I can't, so I go to the next digit. So 38, still I cannot. All right, now the fourth, so look at the first digit, 3, I cannot. Look at the second digit, 38, still I cannot. Third digit, yes, 384. I want to find how many 96 inside 384. And again, this one is outside our timetable range. We're going to use the trial and error method. Okay, so let's just make some guess. So let's say, for example, we're going to think maybe 5. Let's try 5. Well, 5 will be too big. How about 3? Let's try with 3. Okay, so let's try with 3. 3 times 6 is 18. Carry 1. 3 times 9 is 27. 27 plus 1 is 28. Look like still got a long way to go. See that? This is 288. So this should still look like we can add one more. Alright, because this is 288 and that one is 384. So let's try with 4. So 96 times 4. 4 times 6 is 24. 4 carry 2. 9 times 6 is 36. Plus 2 is 38. Ah, bingo, right there. Alright, so that shows 4. 4 works. So 4 times 6 is 24. 4 carry 2. 4 times 6 is 4 times 9 is 36. Plus 2 is 38. And minus 0. Alright, so the assumption we're making is this whole thing is multiplying by 4. Now let's see, this 2 also going to give me 4, but rather than dividing, rather than doing this 1536 divided by 384 to prove this is 4, let's take 384 times 4 will give me that. Much quicker. Alright, so we're going to take 384, we're going to times it by 4, because this divided by this, we want to see if it comes to 4. Am I right? Let's reverse it. Let's multiply this 2 to get to this. Okay, 4 times 4 is 16. 6 carry 1. 4 times 8 is 32. Plus 1 is 33. So 3 carry 3. 4 times 3 is 12. 12 plus 3 is 15. Look at that. They are same. What does that tell you? It is, we're multiplying everything by 4. So we're multiplying this by 4, multiplying this by 4. But now I need to get to this one. So this number times 4 should give me 96. Which also means what? 96 divided by 4 should give me that. Am I right? Because remember, if let's say this is something we don't know. Okay? Don't know. Okay? D times 4 should give me 96. Remember from previous lesson, Max's first law? You're looking for D, which is unknown. So I'm going to bring that 4 across the bridge. Multiplication across the bridge will become what? Division. So 96 divided by 4 will tell me D, the unknown. See that? Okay, so let's use the long division method, which is using the cage approach. 96 into Mr. Mac, I'll put inside the cage. 4 is kind of out, I put outside the cage. In 9, there's how many 4? 2. 2 times 4 is 8. 9 minus 8 is 1. Bring the 6 down. 16, there's how many 4? 4. 4 times 4 is 16 minus 0. That means this is 24. Again, this one times this unknown times 4 should give me 24. But that's in our timetable. What times 4 gives me 24? 6. 6 times 4 is 24. Right there. That's it. Pretty easy, isn't it? Alright, what kind of pattern is that? Times 4. Alright? Okay, good. Now, let's look. Well, give me a second. Let Mr. Mac erase this so we got some room. Alright? Okay, if you're taking notes, go ahead, pause the video right now, write it down, and then play it back. Then by then, Mr. Mac will have the board erased for you. Alright, my students, you're ready for problem D? Okay, problem D. Mr. Mac, I know, but it doesn't matter. Okay, because as long I gave you the sequence with 3 numbers, you should be able to find. Alright? Okay, so I gave you 625, and then 125, and then 25, and then another blank. Okay? So we're going to use this. This is our deciding numbers. Alright? Okay, so what do we do first step? First step, look at the numbers, the sequences. 625, 125, and 25. And we're going to use these 3 numbers to draw some kind of conclusion. The conclusion is this number is reducing. Alright? That means It cannot be addition or multiplication. So the only two can be is subtraction or division. But look, such a dramatic, such a rapid changes. 625 to 125 to 25. So we can make the conclusion it could be dividing pattern. All right, so the dividing pattern. All right, so that means division. So what do we do if it's a division? Okay, so we find two sets. Okay, first sets of number, another set. So we got two sets. All right, so let's start with this one. So what do? We take the first number, divide that by second number. Okay, and then the same thing with this set. First number divided by the second number. Okay, so let's do the first one. Or we can do the easier one first. First number divided by the second number. Okay, so let's take 125 divided by 25. Okay, so we're going to use the long division method, which means cage approach. Doesn't matter which one you do first. The reason why I picked this one first is this one's easier number, smaller number compared to that one. So it will be easier for us to find. You'll see why I'm doing that. Okay, so we're going to translate this into form of long division. So we're going to use the cage approach. 125 is kind of into Mr. Mac, I'm going to put inside the cage. And 25 is kind of out from Mr. Mac, I'm going to put outside the cage. Okay, first digit I cannot. When I go to the second digit, still I cannot. 12 is too small. When I go to third digit, 125, yes I can. But again, its number is outside our timetable range, so we're going to use the trial and error method. So we're going to find 25 times what will give the 125. Let's try 4. 4 times 5 is 20, 0, 2, 4 times 2 is 8, plus 2 is 10, so 100. Still away. Alright, we can do one more. That means I can increase 4 to 5. 25 times 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Right there. So 5 works, okay? So I'm going to put 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Subtract gives me 0. Okay, so the assumption I'm making is I'm dividing it by 5. See that? So now I have to prove it also this one. Okay, so I'm going to take this divided by that. Or this times 5 should give me 625. Am I right? See that? So in other words, 125 divided by 5 gives me 25. But again, we cannot for sure. That's what we just assumed from the first set. Now we got to prove it on the second set. Alright, so we take 625, divide that by 125, and our goal is what? To prove it that also becomes 5. Okay, because if it turns out to be 5, that means it is true, everything's divided by 5. Okay, so how about we do this? We take 5 times 125 and see if it gives us to 625. Much easier, isn't it? So we're going to take 125 times 5. 5 times 5 is 25. So 5, 2. 5 times 2 is 10, plus 2 is 12. 12, carry 1. 2, carry 1. Alright? 5 times 1 is 5, plus 1 is 6. Oh, look at that. It does. So that proves it to us. Everything is divided by 5. So divide this by 5 gives me that. Divide that by 5 gives me that. That means 25 divided by 5 gives me 5. I filled in that one right there. Okay, now what about this one? This number divided by 5 will give me that, which is I don't know. So let's write down. A divided by 5 should give me what? 625. Okay, and from Max's first law, what's Max's first law says? Multiplication cross the bridge becomes division. Division cross the bridge becomes multiplication. Now I didn't earlier, the one for the addition, Mr. Mac didn't show this, but you know that, okay? Keep in mind, multiplication cross the bridge becomes division. Division cross the bridge becomes multiplication. So in this case, we got division. So we're going to bring the 5 across. Well, becomes what? Multiplication. So that means 625 times 5 equals to A, the unknown. So how are we going to do that? Long multiplication. 625 times 5. 5 times 5 is 25. So 5 carry 2. 5 times 2 is 10, plus 2 is 12. 2 carry 1. 5 times 6 is 30, plus 1 is 31. See that? Let's do it again. 5 times 5 is 25, so 5 carry 2. 5 times 2 is 10, plus 2 is 12. 2 carry 1. 5 times 6 is 30, plus 1 is 31. See that? So that means this is 3,125. So 3,125 divided by 5 gives me 625. 625 divided by 5 gives me 125. 125 divided by 5 is 125 divided by 5 is 25. 25 divided by 5 is 5. That's it. Pretty easy, isn't it? Understanding. Now again, if you think you're struggling somewhere, just go back. Rewind the video and watch it again, alright? Go through what Mr. Mac, especially if you think this part is kind of, if you're not sure what it is, right there, Mac's first law, alright? Multiplication cross the bridge becomes division, division cross the bridge becomes multiplication, alright? Kind of like we did over here, right there, see that? We don't know this, so let's say we gonna be B, so we kind of say B times 4 gave me 96, and I'm looking for B. So B is multiplied by 4. So we use Mac's first law. Multiplication across the bridge becomes division. So I brought the 4 across the bridge. So B equals to 96 divided by 4. So we used the long division method and gave us 24. That's why I derived it. Because earlier Mr. Mac didn't show this. I kind of just told you use Mac's first law. Multiplication across the bridge becomes division. Alright? Okay, that should fill in the blank if in case you didn't get that part, alright? And this what? This part, we know A divided by 5 gives me 625. Division cross the bridge becomes multiplication. So that means 625 times 5. That gave us 3,125. Alright, my dear students, you should be ready for your quiz, alright? And look at Pablo. Oh, look at that. He is amazing, isn't he? He knows when to come out. He's been standing there waiting for Mr. Mac to say something. Alright, my dear students, it's time for, and here Pablo. Ding, 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 ding. Alright. Thank you, Pablo. He's great. He's awesome. He's wanted to encourage you. He challenges you. He just dares you. Go get him. Go get him, Tiger. Go do your quiz, Tiger. Alright, my dear students, go have fun with your quizzes. And then come back and I'll see you in the next sub lesson. I'll be here waiting for you. Bye-bye.